We have a question from Frederick Gabriel, and he writes, is it a problem that 80% of miners are located in China? What happens if there no longer is an incentive to mine?
So these are actually two questions, right?
Yeah.
The first, well, you can say it's a problem that 80% of the miners are located in China. I mean, there's still quite some diversity in China, but yeah, it's the whole system of Bitcoin is kind of incentivizing to centralize. Because if you go from an economical perspective, if you mine alone, you will have like, if you use a usual laptop, you will need like 100 years to solve a block. And then you get, right now you get 12.5 Bitcoins if you solve it. But yeah, you see, you take a lot of time and then you will get the reward. What you actually want to have as a economically acting person is a fluent income stream. And this is what happens if you join a mining rig. So it's a connection of people that are creating a rig and then are mining together. So they share the income. And yeah, that's the problem we have right now in Bitcoin, that people are joining all those huge mining rigs because they will have like a small Bitcoin income stream on a reliable basis. But of course, it leads to centralization of the system. There are some approaches how you can have like a mining rig and still being decentralized, but yeah, that's something maybe Griff can say something about. I'm not that much into this centralization part.
Of course. So we actually have a few Q&As, and I can see that we will be tight on time. So I want to reserve the last minute for a very, very quick evaluation. And then I will just ask Felix, we spoke about yesterday the possibility of actually watching a block. Shouldn't we do that as an extra bonus, those who want to stay on 10 minutes after the webinar and see some real code, how a block is made? You got that as a bonus. So we'll stick the last 7 minutes with some quick Q&As. But the first one was the original to you, Felix. I don't know if you prepared it, but we can do a quick discussion about from Søren here. So back to, could you use machine learning to speed up block solving times and thereby lessen security? And then I'll ask another question from Søren. I think it was from Rasmus. Saying, okay, almost the same question as before, why does fast block solving times decrease the security? So if you're able to maybe pinpoint on those two questions, feel free to add in. You are muted, Fabian. Can you unmute Felix? And now we can hear you, Felix, I think.
Yeah, now he's able to speak. And
That's nice.
Awesome. Yeah, I think you can hear me now again.
We can.
Okay, so about the machine learning part. So the block solving time is actually adjusted regularly, because you can also make the block solving time in total faster by just adding more computer power. And that's why the blockchain system is designed in a way that the more calculation power you add into the system, the more difficult the mathematical riddle will be. And therefore the block solving time is actually always around the same time if you just add more computer power or if you decrease the computer power also. About the machine learning part, there are some interesting things about it. I don't think you can use it for the proof of work mining, because the person that is actually the next person going to solve the mathematical riddle is really chosen randomly. Like you cannot somehow try to identify the next person solving a block. But this is something you can actually kind of doing proof of stake mining, because right now all the proof of stake mining algorithms, they're not really choosing the next participant randomly, because you somehow need to get randomness into the blockchain, which is a really, really big problem. So you could use like these kind of technologies to calculate the next person solving a block, and then you could have some benefits. Like, for example, if you know that two people will solve a block at the same time, you can make a transaction. You can make like a thing that is called double spending. So you could make a transaction on one chain, and and then influence the chain that it gets invalidated. So you could do stuff like this if you have the real machine learning power, like if you can pre-calculate the next person solving a block.
Okay. Let's do some very, very quick questions and answers, because we got like 7, 8, 10. So it's going to be your best shot in 10 seconds or something like that. Any examples of national ID systems being based on the blockchain?
I think that they're actually trying to do something here in Neuchâtel, where they are trying to they have a relatively open source voting system, and they're going to move to a blockchain. But that's early stages.
Cool.
I also read some research of Estonia, the government, trying to use a blockchain-based identity system, but I don't know where this is leading to right now.
And maybe another answer to this from audience here, it's Søren Stig, probably involved in the Copenhagen FinTech Lab. He said that, let me see, our focus is on enabling and disruptive maritime trade global shipping. Are you aware of other initiatives of the same space? We hope to build out on the @UN_block trade community quite aggressively the next 12 months. Long question.
I do. I wish I remembered their name. I know there's a place that starts with a T. There's also, I think it's called Providence, which is supply chain. If you Google supply chain blockchain, there are actually, I mean, there's a lot of people coming up with creative ways to solve that problem. So you might talk to them. By a lot of people, I mean like 5. So, you know, I would definitely Google it, and you'll find some really cool projects.
Great. And besides that, I'm thinking that we might be able to, you know, put you guys in touch with each other with these questions on our website, so you can continue on this interesting discussion. And Felix, you had a comment.
Go until 7:30 personally, or even a little later, if the presenter wants to, if anyone else wants to stay.
Yeah, would be fine for me as well. So let's just skip my comment right now.
Another 2 quick questions. What is the future of validation? Is the future really POW and POS? And what do you guys think the alternative will be in the future? From Frederick Gabriel.
I'll say really quick, there is no guarantee. There's really cool projects doing things that are totally off the wall, like proof of resource. Private blockchains do proof of authority. But there's lots of other ideas besides proof of work. Proof of work is going to be hard to beat, so because it's tried and tested. Proof of stake, there's a lot of proof of stake blockchains that have failed because they haven't perfected a lot of the issues there. So.
Okay.
Yeah,
maybe the last.
I think it will be based on the use case probably. There are a lot of applications for blockchains, and not every blockchain needs to be designed for everyone. Like, it can also be between different companies that have a private blockchain or like a company blockchain. They can also use like another thing called proof of identity or proof of reputation. Proof of work and proof of stake are not like the only solutions that are there, but they're like designed for a public blockchain. And I think that still both of them will have a valid reason to exist.
Okay, just a few comments here just on the checking out from Christopher Luckland, is there a way we could use the processing power for calculating something different than random alphanumeric strings? I'm thinking of another type of encryptions. Think like CAPTCHA model. This question might be a long shot, but anyway.
No, not at all. Felix, I mean, I'm sure we can both say things. Do you want to jump in on that one?
Well, I know there are already some projects. One is, I think, called Q&amp, and they're using an algorithm which is based on some kind of protein calculation which helps to progress human medicine. The problem always is just that the adjustability of the difficulty is a problem, because you need a mathematical function that is really hard to solve, but as soon as it's solved, really easy to verify. So yeah, as you see for Bitcoin, you need to calculate every value until you find the right nonce, and to verify, you just need this one mathematical function to use the nonce to calculate the hash value, and you have a verification. And designing an algorithm that has like a real purpose while being so hard to calculate, easy to adjust, and easy to verify is a really big challenge. But there are projects.
Yeah, the most common ones are these CureCoin and folding coin. They do the same thing where it's like you have a protein that's folded a certain way, and you want to calculate how it's folded and how you can unfold it. This is a huge computing resource issue for I think Stanford University uses folding coin, some big U.S. college. But so that's one thing. And then the first example of this was prime coin, which is pretty cool because there's no pattern towards discovering prime numbers. So what somebody came up with this awesome idea of, hey, let's discover all the prime numbers in the world using cryptocurrency. So every time you discover a prime number, you actually, a new prime number is discovered, and then you get prime coin. There was an issue here, is that it's a CPU mine. It's definitely to calculate prime numbers, you don't get any added benefit if you do you can't get an ASIC to do it, and you can't, and your GPU isn't any better than your CPU. So what happened is a bunch of people made viruses that installed PrimeCoin's client on your computer, and now there's all these botnets all over the world that have people's infected computers calculating prime numbers to get PrimeCoin to trade it for Bitcoin. But PrimeCoin's discovered more prime numbers than like anything in the world. It's got all the records, so it's kind of cool.
Yes, the NSA is happy about it.
Wow. Okay, guys, I can see actually that we're very few attendees left, so I think we should call it for the bonus time as well. I have a final comment for one being with us all the time, Søren Stig here. Really appreciate you guys sharing and spending time educating us. Beers on us next time in Copenhagen. So I think this is a very nice final remark from the audience. I am so grateful also for you both from all around the world, actually. Griff from Canada, but right now in Paris, or I don't even know where you are. Is it true? You never know where you are, but you're somewhere in Europe. And wow, Switzerland, exactly. And Felix back in Germany, and us here in Copenhagen, making it possible to meet like this. We'll share all the material on our website afterwards, and if there are questions in written for you guys, try to put everybody in touch with each other. But it was very inspiring and very learning experience for us and me as well. So thank you very much.
Thank you for organizing all this.
Yeah, thank you guys. And be ready, all you computer engineers, learn Solidity. Even if you're just an IT guy, learn Solidity. It's going to be the new lawyers. You're going to write the new contracts for everyone.
Fantastic.